Today, let's go over a medium question that I just solved on my own. I'm really happy about this because I struggled with this one for a long time, and I had to use someone else's solution, but then I came up with my own today, so let's go over it. So you're given an integer array nums sorted in non-decreasing order, and what you want to do is, for the current element, take the sum of every other element minus this element in terms of absolute difference. So if you know what we talked about in the last problem, basically we can use the sum of the right half minus the current number times the length of the right half. So 13 minus 5 times 2, because this is always going to be bigger than this, and then 5 times 2, the length of the smaller half, minus the sum of the smaller half, which is 4. So because we know this is always going to be smaller than this, and so if we want to subtract all the differences between this and this, we just take the length of this times this, and then the sum of this and the difference. We don't have to worry about absolute values because we always know it's going to be smaller or greater on this side. So that gives us an easy way to do binary search. But in order to do binary search, we first have to sort nums. So let's say sorted nums. I actually found out this is faster than sorted list nums, although they technically do the same thing. Sorted list will give you time limit exceeded. So let's go ahead and iterate over nums. Get the current element. So actually we want to create a prefix array as well, because we want to be able to get the sum of subarrays very quickly. So now let's do a bisect left to get this half and the bisect right to get this half. So let's say bisect left inside of S, because binary search only works on a sorted list, and current right equals bisect right inside of S current. And now let's just do this for demonstration purposes. So left is going to be let's say lefts, or S of up to left. Right is going to be S of right to the end. Let's print left, current, and right. So we should make this list. As you can see, sometimes it won't have elements. In that case, that's just a sum of 0, right? So instead of this, we can say if left is bigger than 0, then low, which is the sum of this, is going to just be P of left minus 1, because we know the subarray goes from the start to this point. And then the high is just going to be current times left, because the current element times the length of the left, which is exactly what it is. And then let's declare a variable called now, which is going to add together the difference between high and low. This times 2 minus the sum of this. And we do the same thing for the right. Low and high. So low this time is just going to be the current element times the length of, or just length of nums minus right, because that's just the length of the right list, right? And then the high is just going to be the sum of the right list, which if right is less than or equal to 0, high is just going to be P of -1, because including everything. Otherwise, high is P -1 minus P of right minus 1. And then at the end, again, now plus equals to high minus low. And we want to get an integer list. So append now, and then at the end we can return result. So, and let's submit it. And there you go, passes all test cases. So again, making sure that there are elements in the right list, and then getting the sum of all the right halves minus this, and same for the left halves using binary search. So similar to the question I did previously. So hope you found this helpful, and if you enjoyed, please consider subscribing and stay tuned for more. Thank you for watching.